Solubility is the amount of solute that can be dissolved in a given amount of solvent at a specific temperature. That's solubility. So we can actually conduct experiments to find out just how soluble a salt is in water. Now, what that experiment will generate is known as a solubility curve or graph. And the example is shown on the screen. So that's an example of a solubility curve or a solubility graph. On your graph, you'll notice that your x-axis has temperature and your y-axis has your solubility. Now, solubility is expressed in grams per 100 grams water. So solubility is expressed in grams per 100 grams water. So the grams here would be the amount of salt that dissolved, in 100 grams of water. All right, now because we want to compare the solubilities, what they do is to use one graph, same axes, same scale, and plot different curves. So right away, we have three different salts. We have potassium nitrate, that's KNO3. So that's the curve here. We have potassium chloride, KCl, and we have sodium chloride, NaCl. Now, there are a number of things we can do with these graphs. One, we can just simply find the solubility of a substance at a given temperature. So a question could be, what is the solubility of potassium chloride at 20 degrees Celsius? Another thing that we can use the graph to do is to find the temperature at which a given amount of solute can dissolve in your solvent. So a question could be, at what temperature is 80 grams of potassium nitrate soluble? At what temperature is 80 grams of potassium nitrate soluble? Another thing that we can use a graph to do is to decide on whether a solution, given the solubility, is either saturated, unsaturated, or supersaturated, right? And in the last class, we had defined these terms. So a saturated solution has the maximum number of solutes dissolved in it at that specific temperature. My unsaturated solution pretty much is a diluted solution because it does not carry the maximum and so can accommodate more solute. My supersaturated solution is a special case where I have more than the maximum solutes dissolving in my solvent, but guess what? The condition now is that it is at a higher temperature. All right, so that is my supersaturated solution. Now, how do we know if a solution is saturated, unsaturated, or supersaturated from a graph? This is what we're going to do. So on a graph, we will find the points. I will give, you will be provided with the solubility at a specific temperature. So if it is that I plot my points and I realize that it falls on the line itself. So here's my point and it falls on the line. Let me zoom it for you. All right, and it falls on the line itself. When we have a situation like that, then we say that the solution is saturated. If given the points and it falls below the line, so notice that this is the line here, this is my line, and when I plot my point, it is falling below the line. This tells me that I have a unsaturated solution. But what if I'm given a point and it now falls above the line? So I'm given some points to plot and it is now above the line. So I'm still looking at potassium nitrate here. If it falls above the line, then this is known as a supersaturated solution. Getting me? So look on it. A saturated, let's say this is 130 grams. Let me just quickly look at what temperature it is at. It is at 70 degrees Celsius. So at 70 degrees Celsius, my potassium nitrate will be saturated if it has 130 grams dissolved in it. 130 grams if it is dissolved in it. But look at the situation now. If I place 110 grams at the same temperature, so this here is 110 grams. If I place 110 grams at the same temperature, right? What does that tell me? My max would have been 130. This is my max, but I only place 110. This tells me that I can accommodate more solutes. How many more solutes? 20 grams. So that now tells me, okay, it is an unsaturated solution because the amount that is added has not reached maximum. Good. Now, look at the other situation now. I now have 160 grams. Remember, at 70 degrees Celsius, my maximum would have been 130 grams. I now can get over the amount. So this is now 30 more grams than the maximum. What does that tell me? I have more than the amount, and so it is a super saturated because I have more than the maximum. So those are some of the things that we can explore using the solubility graph. Now, what we did not mention in the last class is looking at terms of precipitate. Now, what's a precipitate? A precipitate pretty much is just a solid that falls out of the solution. So a precipitate pretty much is just a solid that falls out of the solution. So I am going to quickly go back to the diagram, the picture here. Remember this picture that we were looking at? At the bottom here, where you can see the solid, right? Up here would have been the solution. Here is a solid. This is what we call the precipitate. All right. Now, what is going to happen? There are sometimes when a solution is cooled. So remember, you can't keep it at the temperature because it's naturally going to lose energy. The temperature is naturally going to decrease unless you have it constantly heated, right? But anything that you have over room temperature and you leave it alone, it is going to come back down to room temperature eventually. What is it saying now? Sometimes they ask, how much precipitate will form if a solution is cooled? How much precipitate will form if a solution is cooled? So let us go back to our potassium nitrate. Now we have the solubility at 70 degrees Celsius here. However, let's say that I cooled my solution of potassium nitrate from 70 degrees Celsius to 60 degrees Celsius. All right, let me find an easier one, to 50 degrees Celsius. This is easy to work with. All right, so I'm going to zoom again. All right, no, that's too much. All right, now what we need to do is to find out, okay, at 50 degrees, so this is 50 degrees Celsius, what is my solubility? I'm going to read across. At 50 degrees Celsius, I realize that 80 grams can be dissolved. All right, so the question is, if I cool a solution of potassium nitrate from 70 degrees Celsius to 50 degrees Celsius, how much precipitate will be formed? How much precipitate will be formed? Now, what's the idea behind this? This is the idea. At 70 degrees Celsius, I can get an amount being dissolved. At a cooler temperature, I should not get the same amount of salt being dissolved. At a cooler temperature, I'm going to have less being dissolved. So if I add the amount at the high temperature, so the amount that can be dissolved at 70 degrees, which is 130 grams. If I lower the temperature, ladies, it means that some will be left undissolved. So all we have to do is to do a simple calculation, right? At 70 degrees Celsius, I have 130 grams dissolving. At 50 degrees Celsius, I can have maximum 80 grams dissolving. How much is not going to dissolve if I cool it? All I have to do is subtract 80 from 130. That should give me 50 grams. So what they're saying is that if I have a container and if I cool it from 70 to 50, I am going to have 50 grams at the bottom of my container. All right. Now that you have solved that in, let's see if we can work some examples.